Hello everybody, I am Megha Ramesh and I will be explaining the fifth assignment, Design and Analysis of Reconfigurable Systems. In this assignment, we will be programming the D1 SoC board and we will be connecting it to a monitor via a VGA cable to see our output. So we open a new project wizard. In the new project wizard, we select our FPGA like we always do, and then we add these three VHDL files, and then we select top VGA as the top module, and then we compile that first. Then after compilation, uh, since there are no errors, we'll have to make some changes in the VGA controller. So we have to add this part to the program because this is the settings that is required based on the resolution of our monitor. After this, we go install an IP called PLL Intel FPGA IP. Then we name it as TCM Altera, click on VHDL file. After clicking on OK, before that we have to specify a name. We just do DCM. After which, the Mega Wizard loads. And then here we have to specify 50 megahertz and this is 108 megahertz. We have to disable this. I've already done that. And then after clicking on finish there, files are generated and the generated files are added here. tcmaltera.qip and tcmaltera.sip. Then we add the stc file. Then to assign the pins in the pin planner, we already have a .qsf file which is already present. We add that as well. After adding all of that, we compile the entire program. After compilation and after we get zero errors, we click on program device, open programmer, we open it, then we go select our latest .sof file. I've already done that here. After that, we do auto detect and we press start. After pressing start, it's successfully prototyped into our FPGA. After successfully prototyping it, we will be able to see our output on the monitor. Here is the connections made on the FPGA. This is the main power cable. This is a USB blaster which is connected to the laptop. And then this is the VGA cable which is connected to the monitor. Since it's prototyped successfully, this is the expected output according to our program. We get a blue box in the top left corner and there's a yellow background. Particular program, we should also go to timing analyzer and check our netlist. So we go to netlist, create timing netlist. Then we create a netlist. Then we read the stc file. Then we update the timing netlist. After updating it, we check the slack. This is the setup summary slack. It's in positive, it means the timing is met. We check the hold summary slack, which is also on positive, which means the timing is met. Then we go to custom reports. We check this queue. In this queue, we check the from clock from this particular clock to this one, and we report this queue. So when we find this queue, this is the worst queue that we are getting. So we also report the slack for this queue. So this is the slack for all of the other clocks and the clock that we've selected as well. All of these are on positive as well. So which means the timing has been met for all of these. So we will then look at power estimation and analyzer. We click on processing, power analyzer tool. We check this. Then we keep the toggle rate as 12.5. Cooling solution temperature as 50. Then we click on start. After 100% of it is done here, which has already been done, we go to project and then generate an early power estimator file. We've already been given an Excel sheet. So when we go click on our Excel sheet, these are the different power estimator file that has been given to us, EPE file. Then we import the downloaded CSV file into this file. Then we set the temperature accordingly to the way we want. We set the toggle, and we go to logic, set the frequency, go to clock and set the frequency. So when we do it accordingly, when we change values, the static power changes automatically and the total FPGA power also changes automatically. So we test this for different values. To verify if both are the same, we can do that on quarters as well. We go here, we change the toggle here, change the temperature as I showed here. To change the frequency, I will change it in the STC file. Instead of the time period, I take it as 1 by frequency. Since I've taken frequency as 50 megahertz here, I have kept it as 1 by 50, that is 20 nanoseconds. So we can change that, obtain the values on quarters per light as well.